All right, welcome everyone. So we're going to talk about some practice problem for our pre-calculus class. This is a basic concept of trigonometry. We'll see my screen. Okay, you can see the problems. So all these problems test whether you understand basic trigonometry that you need for pre-calculus class. Okay. The question you will get for test 3 will be very similar to those questions. Okay, so please practice these questions a couple of times. You can find similar questions in your textbook or in any other resources you can use and practice with them. Okay, so a lot of practice will give you confidence, and once you're exposed to more questions, it will give you um, better understanding and perform well in your test. Okay, so we'll see the first question. The first question is something you can get like uh, the basic questions that you can answer using unit circle. Okay, the first question, I give you the unit circle and I ask you what is sine phi over 3. Okay, cosine phi over 3 and so on. So how do you answer to this type of question? First, you look at the angle given here. Let's see. Okay, so here. So this is pi over 6, which is 30 degree. And you can see this is the angle you travel phi over 6. Okay. And you know the first coordinate is cosine, second coordinate is sine. That's true for any point. Okay. So sine is your second coordinate. So sine phi over 6 is half. Okay. Cosine phi over 6. So you have to look at that angle, pi 5 over 6. So this is 1 phi over 6, 2 pi over 6, 3, 4. Let me use a different color, okay? Maybe this one. This is 3, 1, 2, 3, 4, 5. Okay, this is the angle. So this is the angle which is 5 over 6. If you want to know what is it's exactly in degree, it's 150 degree. And cosine is your first coordinate. So it will be, let me write it here, okay? Root 3 over 2, but it's negative. In second quadrant, you know, cosine is negative. Any angle in the second quadrant, cosine value is negative. Cosine 2 phi over 3. 2 phi over 3 mean, you can, if you want to know how many, phi over 6 is 4 phi over 6, you know. Phi over 6, 4 times, okay? Let me show you how to get it, okay? You can see this is 1, 2, 3, 4, 4 phi over 6. Or if you think about 2 phi over 6 like this, you know, this is 1 phi over 6, this is 2 phi over 6. Phi over 3, I'm sorry. 1 phi over 3, 2 phi over 3. Okay. So you need cosine, so it's minus half. This is minus half. And then you need cosecant 4 phi over 3. To find that, we will find sine 4 phi over 3. Okay. So you need to find the location of this angle, like the terminal position. How many phi over 3 is 4? So this is like 1 phi over 3, 2 phi over 3, 3 phi over 3, which is pi, and 4 phi over 3. So this is the position. So you get sine. So sine is your second coordinate. So you get negative root 3 over 2. But if you need cosecant, cosecant is 1 over sine. So it's negative 2 over root 3. You can keep this one, without making, rationalizing the denominator. But if you want to rationalize the denominator, it would look like this. Okay? Both can be considered as answers. Okay. tan 11 5 over 6. You know, each of these sector, you know, the angle is 5 over 6. If you go 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the position. So tan is sine over cosine. This is your sine minus half. You divide by cosine. Root 3 over 2. So this will give you minus 1 over root 3. I hope it's clear that how you use unit circle, you know, to find basic trigonometric ratios. I can ask secant, cosecant, cotangent, but all for well-known angles like 5 over 6, 5 over 3, 5 over 4. So here I do not include 5 over 4. You can have the entire unit circle with all the angles include. You can write down that and answer if I ask any other like 5 over 3 problems, you can answer to that. Okay. So let's go to the second one. In second question, you need for first two, again, you can use the unit circle. I'll remind how to do the first question, part A. You need tan 5 over 3. So please check the unit circle. Tan 5 over 3 is root 3 and over 2. 1 over secant, you can write as cosine. Because 1 over cosine is secant, 1 over secant is cosine. So root 3 over 2, cosine pi over 6, you will see it's 5 over 2, root 2 over 2, which is 0 in this case. So check that in your unit circle and you will understand. 1 over cotangent is same as tan. It's tan 5 over. Okay. 2 over cosecant. So it's like 2 times 1 over cosecant. So 1 over cosecant is sine. Tan 5 over 4, 1. Sine 5 over 6, half. And again, it gives you 0. Remember, you got 0 in the both case because the way I put the question, but if I change the question, you won't get 0. You would get some different numbers. Okay. And it's all, again, you find the expression using the trig values that you found in the unit circle. Okay. So how about the part C? Part C is really challenging. Okay. Let's see if I can. So in part C, you need something called cofunction and 3 Pythagorean identities. I'll remind you. So cofunction mean, for an example, sine and cosine, we call cofunctions, which means sine theta is equal to cosine 90 minus theta. So sine and cosine cofunction, tan theta is equal to cotangent 90 minus theta. And the other cofunctions, two pairs of cofunctions, secant theta is equal cosecant 90 minus theta. So you must remember these 3 concepts, including sine square theta plus cosine square theta is equal to 1. 1 plus tan square theta is equal to 1. 1 plus cotangent, sorry, this is equal to secant square theta. 1 plus cotangent square theta is equal to cosecant square. Okay, so I'm going to use these 3 Pythagorean identity, including the cofunction to answer. cofunction concept. Okay, so part C, it says 1 plus sine square of 40, and I keep this one. Sine square 40 I keep. Instead of sine 50, I can use, because if I put 50 here, this will be 90 minus 50. So it's cosine 40. Can you see that I can go back to the 40 again? Because 50 and 40, if you add, you will get 90. Actually, 40 and 50 we call complementary angle. Okay, so that's why you can write sine 50, you can write as cosine 40. If you have square, you can square. Okay, so this is equal to 1 using my first identity. So 1 plus 1 is equal to 2. Okay, so that's how you solve part C. Part D, right? I can change tan square 10 here. Tan and cotangent are cofunction. So I'm going to change tan square 10 to cotangent square 80. Because I can change 10 degree 10 to 80. And when I change it, I change tan to cotangent. That's one of the related. For example, if you have 10 here, you can put 10 and 90 minus 10 is 80. And this is, I keep cosecant square. So cosecant square, if I bring this to other side, it's like cosecant square 80 minus cotangent square 80. So this is really plus 1. This is okay. The minus, actually you have minus, but if you bring it to other side, it's become minus. It's again 2. Okay. How about E? Okay. I'm going to erase a few of the previous parts so we can get this. Here you go. I erase. I start E here. Okay, so this is the one. So cosecant 37, you know, cosecant and secant, they are cofunction. For cosecant 37, I can write secant 53. This one, okay? And I have secant 53 again, so I can put a square. Minus tan 53 I keep, but if you see the cotangent 37, I can change cotangent 37, because if you put, you know, cotangent 53 is equal tangent, sorry, cotangent 37 is 37 is equal to tan 53. So it's a tan 53 again. So I'm not going to write again. So I put a square. Secant square. So if you see this one, let me highlight here. Oops. Okay. Okay, I'm going to use this one. Okay. So if I bring tan to other side, it's minus tan square. So this will be 1. Okay. Clear? I hope it's now clear. Okay. All right. So I'm going to do the last one. F. Cosine 12, I can keep cosine 12. Sine 78, I can change to cosine 12. Why? 78 and 12 are complementary angles. Sine 78 is equal to cosine 12. So cosine 78 is equal to sine 12. Can you see now I have another sine 12 in the question, see? And it seems like I get cosine square 12 plus cosine square 12, which is 1 because of the first identity. So you can see you need to remember cofunctions like sine and cosine, cosecant and secant, cotangent and tangent. Those are cofunctions, including those three Pythagorean identities. So I'm going to give you a question that you need those. Okay, right. So let's go to question number 3. Question number 3. So you have a point given in the third quadrant. It could be any quadrant. In this case, I give you a point on the third quadrant. I may give you a point on the second quadrant, fourth quadrant, first quadrant. So all what you want to do is remind how we did, like, when you have a, so let me, oops. Okay, so here we go. So if the point is in the third quadrant, it's somewhere here. Somewhere here. This is P -5, -12. Okay? This is the point. Okay? The angle I can call theta. The angle is greater than 180. Can you see that? This is 0. This is 180 degree. So this theta is even more than 180 because it's in the third quadrant. In the third quadrant, you definitely know the sine cosine is negative, tan is positive. Okay, but how do you find sine theta for an example? Sine theta is always your y coordinate, but the real formula for sine theta is y over r. Since you used unit circle so far, in the unit circle, the radius is 1, so you can put 1 always. It's like always your y coordinate is sine. Your x coordinate is cosine. But now, this point is not on the unit circle. Okay? Because you can see your x, y value are both greater than the, I'm talking about the absolute value of those coordinates are greater than 1. So you have to divide your y coordinate by r. So I'm going to put r here and x coordinate by r. What is that r mean? The length from origin to the point. So this is -5 and this is -12. But to find the r, you square the x coordinate. Oops. You square the x coordinate, you square the y coordinate, and you take the square root. It doesn't matter x, y, negative, because you always get positive when you square. So if you square -5, you get 25. If you square 12, -12, you get 144. And you take the square root. This will be 169. If you take the square root, the radius is 13. Clear? So I put x equal -5, y equal -12. And I plug those values here and here. Okay? And that gives me 30. So once you get those values, it's very easy. Sine theta is y coordinate, which is -12 over 13. Remember, you have to put r. Cosine theta is x coordinate, which is -5 over 30. Both sine and cosine negative. What is tan theta? Tan theta, by definition, it's y coordinate over x coordinate. So this is your y, this is your x. So if you divide a -12 by -5, you get 12 over 5. Okay, so yeah, it's third quadrant, tan is positive. Sine, cosine, negative. Very clear. And it's verified by my calculation. How do you find cosecant? You can write cosecant theta as a reciprocal of sine, which is -13 over 2. Secant theta is the reciprocal of cosine, -13 over 5. cotangent theta is not 12 over 5, but 5 over 12. So that clearly explains how you can find all 6 trigonometric ratio when you know a point on the xy plane, and the angle is the angle that travel from the x-axis, positive x-axis to the to that point. Okay, right, right. Right. It's later you can learn something called polar coordinate. When you learn the polar coordinate, you can understand any point on our Cartesian coordinate system can be represented using polar coordinate, where how much the angle you travel to get that point, plus, including the radius from the origin, like how much the distance from origin to that point. Okay, right. You can do this calculation for any point. If I give you first coordinate, second coordinate, or third, fourth, anyway. Right. So fourth question, if you see this question is little challenging question. So take like 1 minute, 1 or 2 minutes to read the entire question. It says a researcher is studying the movement of species of fish in a lake. Okay. Let me make it a little zoom. Okay, here. Here. A sonar device placed at the lake edge detects a fish swimming at a depth of 8 times root 3 meters below the surface. So I can think it's like, we use a different color, maybe blue one. Okay, so this is the surface of the lake. Okay? This is horizontal. Okay, you can think this is the sonar device. Okay, place the sonar device here. At first, they explain a fish swimming. So this is my fish. Okay, swimming deep in the lake. Deep down, how much the length? 20 times root 3. Okay, below the surface. The sonar device records. So you can think this is as some distance or anything, like you can take it as L. Okay. The sonar records the angle of depression to the fish 45 degree. So that means from here to here, the angle of depression. So I'll try to draw it like this. This is 45 degree. Okay. It's 45 degree mean this is also 45 degree. So if you think about this triangle, it's a right angle triangle. Okay. And I can find out the distance from the bottom of the sonar device. So this is the sonar device. The distance from the fish to the sonar device, the bottom of the sonar device. I can say this is B. Okay. So the first position of the fish, I can say A. So D1 or AB, I can find, considering my triangle. I can put S for sonar device. So if you consider ABS triangle, I can write tan 45. Tan is what? Opposite over adjacent. Opposite is D1 over adjacent. Tan 45 is 1. So I can replace tan 45 by 1, and you get the distance D1 is 20 times root 3. So if you put root 3 is equal to 1.7, and 20 times 1.7 is 42 meters, 34 meters. Sorry. 34 meters because it's like 17 times 2. Right. After a certain time, after they say after 2 minutes, the fish moved. The fish is swimming, and maybe it come to the situation like this. This is the place now the fish is staying. And the depression angle is given as 60 degree. So that means from here to here, the angle is 60. So that means this angle is 30. Now I can say this point is A, B. I didn't use C, so let me choose C. So if you use BSZ triangle, BSC triangle, and put tan 30, its opposite, which is how much the fish now from the bottom of the sonar device. So D2, let me say for the D2. D2 opposite over adjacent. Adjacent doesn't change because it's the length or the deep from sonar device to the, the horizontal line that fish is swimming. So if you do tan 30 is 1 over root 3. So D2 over 20 times root 3. So if you cancel that, you get D2 as 20. So that's mean that what does this really mean? At the beginning, the fish is 34 meters away from the point B. After 2 minutes, it's only 20 meters away from the point B. So I can say part A, for part A, find the initial horizontal distance. Initial horizontal distance is D1, which is 34 meters. That is the initial horizontal distance to the fish from the sonar. Okay. Horizontal mean this distance. Okay. Find the new horizontal distance, which is D2. Oops. Sorry about that. Here. It's 20 meters. Calculate the total distance traveled by the fish within 2 minutes. Within 2 minutes, it's traveled D1 minus D2. Because I need this length. This length you can get by D1, subtract this from this. So it's like 34 minus 20. It's traveled 14 meters within 2 minutes. Okay. So the speed of the fish in meters per minute. So it's 14 meters travel in 2 minutes. So the speed of the fish is 7 meters per minute. Okay. That is the speed of the fish. So this is like a basic trick question that you can use to calculate kind of some application or real world example. Okay. You can calculate the speed of a fish, the speed of a bird, height of a tree using this simple calculation. Okay, I think it's clear. You put tan 45 for first situation and you get D1, and you use tan 30 to get the second situation and you get the D2. The difference between D1 and D2 gives you how far the fish travel in that within that 2 minutes. Okay, and if it travel 14 meters in 2 minutes, which means the speed is 7 meters per minute. Okay, right. Number 5. So this is I think this is a great question because you can see so far you can I can give you the angle and you can tell me the sine value, cosine value, and so on. Here I give you the value of the sine and you need to find the angle. Remember, this is not an inverse problem. Okay, this is not inverse trigonometric function. So because of that, in the first, in your unit circle, if you think about 0 to pi mean like a one period, you can say. Within one period, sine, cosine, tan, if I give you a value, you should be able to find two angles that gives you the same sine value for an example. You can check the unit circle, but I will quickly draw. Let me, maybe I'll remind, okay? So let me see. Yeah, here you go. So I can take a circle and hopefully I can draw it. Here you go. Can make it a little bigger. This. Oops. I don't need yeah. I think it's good. Yeah. So now this is this point. If you go 45 degree, this is like 5/4. This point is √2/2, comma √2/2. Sign is positive here, and you can have similar situation here, which is you go another 45, another 45. I'm going to put 5/4 here and here, okay? So this is, you can write it like 0, 1. This is your x coordinate is negative, but your y coordinate is positive. You see, sine 45 is √2/2. Sine 3/5/2, 4. That means 3/5/4 means sine 135, also √2/2. So there are two angles that gives you same value √2/2, which is 5/4 and 3/5/4. Can I get sine angle equal to √2/2 here? No, because sine is negative here. Sine also negative in the fourth quadrant. I know sine will be positive in first and second quadrant. So therefore, I can find 2 theta value. Sine of that angle will be √2/2, which is 5/4 and 3/5/4. So first, that's what you want to do. So for an example, first one we done. So if you need sine theta equal to √2/2 negative, I know sine will be negative here and here. So always √2/2 connected with 5/4. So this is 5/4 again. And the other point is here. So it's like 1, 2, 3, 4. That means theta will be 4, 5/4. Sorry, 1, 2, 3, 4, 5. 5, 5/4. 5, 5/4. 6, 7, 5. These are the two theta value. The sign of those theta values will be negative √2/2. So how about the other one? So C. So I'm looking for tan theta is equal to negative √3. Okay. How do you get that? I'm going to draw this one more time. Okay. Just to give you the idea. So I'm going to, it's a kind of a, it's a little bit oval shape, but it's okay. It's okay. It's not a big deal. Let's do it. Right. It's not great. looking for my circle, but it's simple. I'm going to change. Yeah, it's okay. Uh, Tan is positive here. That means any angle between 0 and 90 would not give me negative number. Here tan negative, tan positive here, and positive negative here. So I know the angle should be somewhere here, the second quadrant or fourth quadrant. So root 3 connected with 60 degree. Remember tan 60 is root 3. So you can find the reference angle here is 60. So reference angle is the angle that you always make as a reference of x-axis. So this is like, you can think it's like 120. The amount you need to travel is 120 degree. So one of the theta value is 120. You can write it's 2 pi over 3 because pi over 3 is 60. So 2 pi over 3 is 120. The other angle is here, but it's positive. So this is, you can think it's like this all the way to here. So let me draw it. The other one is here. That's the 60. The reference angle is 60. So always tan 60 is root 3. But since this point is in the fourth quadrant, this is like tan, the angle is entire angle, if you need 300. Tan 300 is negative root 3. So 300 is like 5 times 5 over 3. So these are the two angles. The first one lie in the second quadrant. The second one lie in the fourth quadrant. Both gives you the reference angle 60, which mean we know the tan 60 is root 3, but because of the two angles lies in the second and fourth, it gives me negative root 3. Okay. How do you do cosine theta is equal to negative half? Cosine, I can draw, you don't need to draw all the time. So if you get the idea, you can quickly get, and because you have the unit circle with you, right? You don't need to always draw. You can check the unit circle and get those values. Negative half. Half is related with cosine pi over 3. I know cosine pi over 3 is half. Cosine is negative here and here. So that means you go 60 up and 60 down. So if you make the reference angle 60, you get those 2 points. This is like 120, which is 2 pi over 3. The other one is like 60 more than 180, which is like 4 pi over 3. Okay, these are the two angles. 60 I got because cosine 60 is half. So there are two angles gives me cosine theta negative half, which is 2 pi over 3 is in my second quadrant, 4 pi over 3 is in my third quadrant. How about tan theta 1 over root 3? Tan theta 1 over root 3. I know one of the tan is positive in the first and third quadrant. So I can draw it really quick. So root 3 can get using 30 degree. So tan 30 is 1 over root 3. I'm sorry, it's not root 3, 1 over root 3. Okay. So theta is equal to 30. I can write 5 over 6. The other one is, because tan is positive here, the other positive angle is here. So 30 degree in the reference. The reference angle is 30 mean 180 plus 30. So it's 210. The other degree is 210. If you need it in radians, it's 7 pi over 6. Okay? 7 pi over 6. That's how you do it. Always think about the reference angle by looking at the value and consider the sign plus minus and find the correct quadrant. Okay, that's all you can do. Okay, right. Number 6 is drawing. So when you draw the graph, you can draw the both graph in the same. So I'm gonna, it's going up and down anyway. So I'm gonna draw it here this side. Okay. See it. Oops. I'm gonna erase this. Okay. Can I'll use this one. Okay, I don't need my positive, negative axis actually. Oops. I'm going to extend this. I'm not going to use negative direction. Usually you draw the graph positive direction. Okay, because it's the same thing. You can repeat. So if you look at the first graph, the amplitude is 4. What is the period? Period is 2 pi over this number, 2. The period is pi. Can you see? Period is pi. This will solve to pi. Okay. That means you take the pi, maybe you can mark it here, and you divide the period into 4 pieces. I always mention it. Okay, so you divide the period into 4 pieces. It means it's become 5 over 4. These are the turning points. Your graph change. Because those 5 over 4 is kind of a quadrant, like a 1 quarter. So it's go up 4 here, up to -4. So let me see if I can mark those lines, okay? This is -4, this is -4, it's not very, that's okay. You can roughly draw, okay? And sine, if I plug 0, sine 0 is 0, so sine start here, okay? And if I plug 5 over 4 for x, you can see it's 5 over 2, because it's 2 times 5 over 4. And it gives me 5 over 2. So I know sine 5 over 4, 2 is 1. Because of the 4 here, it goes here. It's like a same sine graph, you reduce to 0 to pi. The normal sine graph is from 0 to 2 pi, but this time it's from 0 to pi because of the period change. Okay, here you go. Now you need to draw the other one, which with the phase shift. The phase shift you can get by taking 2 pi over 3 divided by the number here. It's like C over B, we remember it. Okay, so this is 2. So I get 5 over 3. So you take the blue graph, 5 over 3 to the left, sorry, right, because if you have minus here. If you have plus, you shift the original graph to left. If you have minus, you shift the graph to right by this amount, 5 over 3. 5 over 3 is more than this, right? So you have to be a little careful because this is like 45. So this is like 60 degrees. So that means this point goes to somewhere here. Okay. It's 0. This situation, this goes to here. The gap now is 60. This point goes to somewhere here. So it's start like this. Same piece here, transform to this. I'm going to erase this one. That's not really happening. Okay. This point goes to somewhere here. This piece that I draw using blue now transform to the one I draw here. Okay, and see that. It's like it shift 60 degree to the right. So this will be like you going like this, for an example, this point goes somewhere here. Okay, it's enough you draw it now. Okay, it's good. This is so you need how much it's shift. This number is pi over 3. Pi over 3 I got. That's all. That's how you draw it. The blue one is 4 sine 2x. The yellow one, 4 sine 2x minus 2 pi over 3. And you can say where it's start. It's pi, for example, you can say the gap I over 3. Okay? You don't need to mark all the points. If you tell me where you start and stop, then I feel understand you got the concept. Okay, right. So let me quickly go to the last one. So the last one, you need inverses. So remember the principal range of sine inverse. If I ask sine inverse of any value, you tell me the angle between negative 90 to positive 90. It's called principal range of sine inverse. For sine inverse, you get 0 to pi. Tan inverse, you get negative 90 to positive 90. Part A, cosine inverse root 3 over 2. For which angle cosine become root 3 over 2? Cosine 30 degree. Cosine 30 degree is root 3 over 2. 30 degree, I know it's in this range. I can answer cosine inverse root 3 over 2 is 30 degree, which is 5 over 6. You can put 30 or 5 over 6. Okay, for part B, secant inverse, before that, you have to find cosecant 3 pi over 4. So you can find sine 3 pi over 4, which is in the second quadrant, is root 2 over 2. Cosecant is like 2 over root. What is this? Okay. So it's like secant inverse root 2 over 2. Okay. Then you can find, for sine 45 is what? For sine 45 is root 2 over 2. So secant 45 is 2 over root 2. That means secant inverse of this is 45. That's how you get. It's a little tricky because you find cosecant and you find the secant inverse of the cosecant 3 pi over 4. Cosecant 3 pi over 4 is 2 over root 2. Secant 45 is 2 over root 2. So you can get the angle as 5 over 4. Okay, because secant 45 means secant 45 over 4. You can put 45 degrees. Same thing. See, finally, you can think like you need to find cosine tan inverse pi over 2. I don't know the angle, the tan theta, or whatever the angle theta, the tan of that become 5 over 12. So I can say tan inverse 5 over 12 is theta. So tan theta then become 5 over 12. It's an inverse function. So if I know tan theta, which means I know my opposite and my adjacent, because tan is opposite over adjacent. So I can find hypotenuse by Pythagorean Pythagoras formula. It gives me 13. I did the similar. So that means I need cosine of tan inverse 5 over 12. Tan inverse 5 over 12 I choose as theta. So I can find cosine theta because they are same. But cosine theta I can find using this, which is adjacent over hypotenuse, which is 12 over. That's how we see it. Okay. All right. I think it's very clear. Um, all right. Study the question and let me know if you have any concern or any doubts. Okay. Good luck.